Craps probability can look intimidating when all the math is flying around, but it's easier than it seems. We're going to make it simple, break it down step by step, and show you what those numbers actually mean in the game. Stick around, and the probability will start to feel easy to understand. So what we have here on the screen, if you take two fair dice and you roll them thousands and thousands of times, what you're going to do is you're going to see pretty much this distribution among the numbers between 2 and 12. It's going to form a pyramid shape with a 7 being in the center of the pyramid, falling off equally left and right, the 6, 8, 5, 9, 4, 10, 3, 11, 2, and 12. So what that does is that will show us the distribution between the different numbers. Now, obviously, the 2 and the 12 are the least thrown numbers, and I like to call those sisters. Matter of fact, any number that is thrown the same amount as another number would be sisters. So in this case, a 2 and 12 are sisters. They each can be thrown one time. A 3 and 11 are sisters. They can be each thrown two times. And we work our way up the pyramid. The 4, the 10, each can be thrown 3. 5 and 9, each can be thrown 4. The 6 and 8, which are the second most common numbers, can each be thrown 5 times. And our buddy, number 7, he can be thrown the most, obviously, 6 different ways you can throw it. If you add up all these combinations on 2 fair dice, there are 36 possible combinations that you can throw. But in order to do probability, we don't need to know 36 combinations. We only need to know 6 because they're reciprocals. They're duplicates of each other. We don't need to learn how to do a 2 and do a 12 because they're the same. So the definition of probability, or the equation, if you want to call it, is universal no matter what we're doing here. It's the probability of rolling a specific outcome using 2 fair dice is equal to the number of ways to roll the outcome divided by the total number of possible dice combinations that matter in that roll. And that's the important part for the equation. It's the combinations that matter. So in the case of a single roll bet, such as a horn bet or a field bet or the hops, your bet's going to be resolved on the next roll. Win or lose, you're either getting money, they're taking your money, it doesn't matter. It's going to be done that roll. So that's a single roll bet. So in that case, if you have a horn bet, say you're betting a 2. Well, we know there's only one way that you can roll the 2, but there's 36 combinations that can come out. So your probability will be 1 divided by 36, or 2.78. And since you know that, you know its sister, the 12, has the exact same probability of 2.78%. The same will be true on any of the other numbers. A 3 and 11 both have 2 ways you can roll it, shown in the picture there. Still 36 ways possible for a total of probability of 5.56%. That's it. No matter what you roll, a 3 can come out 5.56% every time the dice get rolled. A 4 and a 10, 3 ways to roll, 36 combinations, 8.33%. 5 and 9, there's 4 ways you can roll it, 11.11%. A 6 and 8, which is the second most common numbers, which is why they're popular place bets, they can be rolled 5 ways out of 36 combinations for a total of 13.89% chance of winning on that roll. And our 7, which is the most common, every roll of the dice, you have a 16.67% chance of seeing it, which is why every bet in the game is based off of this chart. You can't beat it. The house has it set to where no matter what bet you make over time, that 7 at 16.67% is going to beat you. You just can't do anything about it. You just try to hit it when you can, get your money, and you leave. That's all. Okay, so now that we've kind of got the understanding of a single roll bet probability, we need to take the next step for the second type of probability in craps. There's really only 2, the single roll bet when it gets resolved on a single roll, and what I like to call the race probability, where you have two or more outcomes that could be happening based on the roll of dice. Uh, so a race, basically, it's whoever gets there first wins. You can't race alone. That would not be a whole lot of fun. It'd be like having one walkie-talkie. And it'd be pretty bad if you actually beat yourself if you raced alone. So you got to have at least two participants. So in this case, we actually want to examine the non-single rolls, which would be place bet, delay bet. Uh, you could say this part of it is the pass and don't pass and the come and don't come, but those are special because they're going to be combinations. So we're really going to concentrate right now on the place bets. So if you look at the 4, the probability that a 4 will roll before a 7 is almost identical to the single bet roll, but now we don't have 36 combinations. We don't care about anything except for the 4 and the 7. So we know there's 3 ways to roll a 4. We know that there's 6 ways to roll a 7. So the probability of the 4 rolling before the 7 will be 3 divided by 9, because there's 3 ways to roll the 4. There's 6 ways to roll the 7, which is 9. So 3 over 9 gives you 0.3333 repeating, which is 33.33%. That's it. If you place bet a 4, you only have a 33 and a third chance of winning that bet, no matter what happens. And it doesn't matter if it takes 1 roll or 10 rolls. It does not change anything because you don't care about any other number but the 4 and the 7. Now, since, the 4 and 10 are sisters, the 10 obviously is the exact same probability. It's 33.3%. If you move over to the 5, you have 4 ways to actually get the 5. You still have the 6 ways that you can roll a 7. So now your equation is 4 divided by 10, which gives you 40%. So you've increased your odds from 33.3 on the 4 to 40% on the 5 and its sister, the 9, if you happen to bet on the 9. And then if you jump over to the 6, there are 5 ways to roll your 6. There are 6 ways to roll your 7. That gives you 11 possible combinations. So if you follow the formula, it'd be 5 divided by 11, which is 45.45%. And likewise, its sister will also be 45.45%. And those are your race probabilities, because if the 4 or your place bet, the 4, the 5, or the 6 hits, that's your winner. If the 7 hits, then you lose. And that is the basics of those types of probabilities. Now, I would like to make a couple of caveats to this, just in case so everybody's clear. So in the case of a 6 you're betting, you have obviously a 45.45% chance of winning that bet. And a lot of people will say, I'll throw the 8 on there. I'll get 5 more chances to win. And their brain quickly and mistakenly goes to, I got 10 chances. I've doubled my chances. I have a double probability to win. No. Yes, you have twice as many chances to win, but your probability does not go up by double. It's actually now the probability of your 6 hitting, which is 45%. Plus, you got to add in the other 5 chances, which is another 45%. But when you do the math, you actually get 10 divided by 16, which comes out to only 62.5% chance of winning. You do not double. It is better, but you don't get what your brain immediately sees to have, and what I hear people say mistakenly all the time. So I just want to be clear on that. When you add other numbers in, you get a better percentage, a probability to win, but it's not as high as what people think. It actually approaches, 100%. But it never can get there because you can always get those 6 ways to lose. Okay, so here I have written a small simulator for doing my different crap strategies. It is definitely crude. It does not look like a regular table, but I can set things, different strategies I want. I can set how many rolls, how many shooters, different bank rolls. It's still a work in progress, but for what I want to show you here is the dice probability, how for us playing on a given day, that bell curve really doesn't come much into play. We're not there long enough, you know. So I got to set right now is I'm going to limit myself to just run 10 shooters. I'm going to run the sessions, and you can see on the screen, this graph of these rolls does not look that nice bell curve. We got 106 rolls for those 10 shooters. We didn't even get a 12 that came out. You know, our come out wins, we had 30% instead of what's supposed to be around like 22. We had 6% losses, come out losses. It's supposed to be 11. So you're not approaching the mathematical probability of these rolls. You can see we had a lot of come out 7 winners. That's the greens. But if I run it again, you'll see this graph changes. It's all over the map for 10 shooters. Now, if I change this, and let's say I want to see 100 shooters. Now I got 892 rolls. The graph's starting to look better. It's, the sevens are the highest and they're 6 and 8. So you're getting that little bit of a bell curve, but it's still not perfect. And that's 892 rolls. I mean, even if we do 1 roll a second, let's see if you do the math on that, that comes out to be almost 15 hours of gameplay to get those 892 rolls. I don't know about you, but I'm never there really for 15 hours. Most of us are there roughly for, let's say, 2 to 3 hours. So let's say you're there for 3 and a roll every minute. That's 180 rolls. So instead of limiting this to the shooter, let's just change this max per session to only show us 180 rolls. And now you'll see it. We got 180 rolls. Yeah, it's not bad. The 7's a little bit low. We got a lot more 6s and 8s than we should. But again, look at this graph. Every time, 180 rolls, we're all over the map. So I just wanted to show you that for when we're there to play, this mathematical probability, the theoretical, what's this graph going to look like, more than likely doesn't follow, which will lead us into the next videos with the EV and the house edge, and really what does that mean? What's the definition? And, then for strategy play, that's where this all goes, is what do we want to do for the strategies? So, and if you all notice, my cat's up here on my lap. So if you see a tail fly by, that's it. She has no personal space, but that's okay. So again, I just wanted to show you this simulator. It's not for everybody's use. It is for my own personal use. So there are some flaws in it, and it looks pretty crude. So I hope this helped you understand, that we're all just there at the mercy of the dice at any given time and any given day, and nobody's there long enough to really see the true bell curve. You also have many different probabilities going on at the table at the same time. How you bet is going to affect your probabilities. It's not going to affect my probabilities. And you could have multiple for yourself. You could have bets on the 6, and you could have a different bet on the 9. And each one has a different probability to win. And you could add them up together, and you get a different number. But they all come back to the same foundational equation that we did in the beginning. It's the amount of combinations that make you win divided by the total combinations of the dice that resolve your bet. And that's it. It has to be the ones that resolve the bet. Anybody else, it doesn't really matter. So I kind of just want to close this out just to summarize what all we talked about. I know a lot of this was pretty basic for many people out there. you know, they've been doing this a long time, but I hear a lot at the table. Some people throw around terms and numbers that quite aren't right. So I just wanted to kind of make it simple. But, you know, there's two types of probability in craps. There's a single roll and the multi-roll, or I call the race roll probability. Single roll, you know, horn, hops, field, any craps, any 7, world bet, C&E. Those are your one roll bets. Your bet will be resolved at the end of the roll, win or lose. Then your race bets, they are, you know, if a certain number happens before another number, 5 before 7, 8 before 7. Those are your place bet numbers, stuff like that. So I hope you enjoyed this video. I hope you got something out of it. Leave some comments. Tell me what you like, you didn't like. I tried to make it as simple as possible without using a whole bunch of math and jargon that, you know, just isn't unnecessary. If you did like it, please like and comment and subscribe to my channel, and I will see you on the next video. Until then, roll the point.